Hello, everyone. Happy to be here. Today we are going to talk about data versioning in generative AI, about efficiency, and what is special about generative AI from the data point of view. A little bit about myself. I was data scientist at Microsoft Bing for almost 5 years. Have seen how large teams are doing machine learning. And later I created an open source DVC, data version control tool. Anyone familiar with DVC? Yeah, thank you. Quite a bit of folks. And DVC was a foundation for the company, Iterative AI. Sorry. DVC was a foundation for the company, Iterative AI, when we built tools for machine learning, usually with a high focus on the data side. And today we will talk about generative AI from the data point of view. What is special about data company and data set management? What is data set? What multimodality changes on data from data point of view? And how to be efficient when you work in these use cases. I will be referencing two papers. One paper is data competition, data comp. It's about a large-scale multi-model data set, so that's a good source of examples, data, and when you can play ideas and data you can play with. And the second paper is from our team. It was presented 3 weeks ago on ICCV. It's about generative AI, data tool set, right? This is something that will be foundation for the next DVC, if you wish, at least on the ideas level. So, what is special about generative AI? How generative AI changed the data landscape and data versioning landscape? First, the obvious one is unstructured data, right? On traditional machine learning, you have structured data, tables, data warehouses, data frames, like BI, ETL, everything. Beautiful tool set. Here, when you work with the images, LLMs, you have literally nothing. You put your data, JSON files on a S3 drive, right, or images or videos, and then what? Majority of the team just write Python scripts, right? So that's the reality. Second part, which makes it more complicated, is multimodality. You need to deal with the text and images together. You need to merge them, combine them, work with them at the same time. And it becomes even more complicated. It's not only about multimodality, it's also about different signals that people use. So this is how multimodality looks like, right? You might have images, files on your S3 drive, and at the same time, each image has a caption, right? That's an example from the datacomp paper and Lion dataset. Stable Diffusion was trained on this dataset. And scale makes everything much more complicated. If 3 years, 5 years ago, we mostly were working on the scale of thousands, dozens of thousands of objects, files, today we are dealing with millions and billions. Lion dataset, it's 12 billion of images, pairs actually, image plus text description. Right, it's a huge scale, big change. Everything changed when you get to the scale of hundreds of millions and billions. It's you understand mechanics, right? You understand how the world works, and when you start thinking about space, light speed, it doesn't work anymore, right? Your intuition doesn't help you to understand this. The same with this huge scale of data. No tools working, and you need to re-implement all the stuff again. And the thing become more and more complicated. We are incorporating more modalities. Video became the first, the frontier in research, and very soon we will have a lot of new models with the video, which has multiple modalities. Images together with audio, together with the text, together with description of what's going on the scene, right? So the world is become more complicated. The scale increasing a lot. How to survive in this generative AI landscape? How to manage data in this situation? So the short answer is you need a good data structure, as usual in computer science, right? You need a good data structure, operation of the data structure. So, and let's go through those ideas. Idea that we found useful when we talk with the teams, right, in different companies, from startups to like large enterprises. And we want to share like the ideas that we know work really well. And some of those ideas, good portion of those ideas will be incorporated in the future DVC. So, data sets. You need a good abstraction of the data set because it helps you to just better manipulate, be efficient. And the first part, which is needed, is versioning of the data set. When someone trains a model, the usual question is like, what data set was used to train this model, right? And the answer is like, oh, the latest one. But the thing is, how about next week? Will it be the same data set next week? Likely not. Did you apply any changes to the data set? Very likely you remove some files. Very likely you modify some description. Very likely you change the labels, right? So it's not the same data set that you can think about. So the first thing you do, you just like version data by directories. It works okay-ish, especially in a small teams, in a small scale. But you, at some point, will hit the limitation, right? You don't want to waste extra space, right, by creating like hundreds of copies, especially with a larger data set, like line, right? Line is like 50 terabytes or so, the whole data set. In practice, we see a lot of data sets with dozens of terabytes. But even for small ones, it's really easy to get lost. You don't want to waste time on this, like constantly copying, sharing and stuff. And it's not useful for collaboration, right? What you want to see, you want to collaborate by like one single sentence. Oh, I use dataset version 2. Or very simple use case, like every company come up with this idea like super soon. Let's just create some, I don't know, list, like CSV file with references to the file names in your storage, right? That would be my data set. So that's improve your process quite a bit. First of all, you understand what the version is, right? So you can take a look like what exact file was used. You can easily like do, relatively easy do like different types of diffs. Okay, this is a new data set. How is it different from the previous one? From CSV file, Parquet file, you can like easily do this. And it's easy to send it. You can just Slack it if your data set is small, right? Or share it through some storages. So it improves the way how teams collaborating, right? So that's an example of like a diff, how you do like a diff on the data set. Some use it like our library, but you can implement this fast, right? So give me a data set, the latest version, look at the bucket in the storage, give me only images from the storage, and subtract one from another. So I want to see what was changed in the data set. So this operation is supposed to be like super easy for you, right? Because you are usually doing this like very often. The challenge in this approach is file modifications. So if file was changed, removed, or added, that's easy to recognize. But what if it was modified? And the short answer is you need some checksums to like keep consistency in the data set. And there are a lot of ways of doing this. All the cloud storages support e-tags or checksums, right? Some of the storages support file versioning inside, and you have like version supported in S3, for example. Timestamps in the local file system might work. So that's something that you need to keep in mind, right? Don't forget to include this like information for the consistency. And this is like how the current DVC works. If you like use DVC, right, you know that DVC kind of creates this like CSV files, if you wish. So reference to the data competition again. Smaller scale data set on the Datacom is 12 million of images, actually combination image text, right? Goal is to train the best model, but you cannot modify the code. What you can do is remove data samples, remove files and description. That's the only operation you're allowed to do. And so far, the best result is accuracy was improved like almost 2 times just by removing data. 63% of the data can be removed, and your model improves Accuracy improves 2 times, right? And competition is still going, right? I believe they will get like a few more % of improvements. So, and again, that's a very usual stuff. Very likely you have seen this multiple times, right? When you just remove bad samples from the data set and model become better. And in order to efficiently share this information, right, how you can communicate I was trained on this data set, you can send the set of IDs of images or file path of the images. So this would be like your data set that can be trained, and you get the result. So simple but efficient way of collaborated conversioning. This approach does include multimodality. Right? So far, we were talking about files, nothing else. But in fact, that needs to be incorporated. You need this multimodal approach kind of built in on your data versioning machinery. What does it mean? It means in simple case. In simple case, your quoted CSV file need to contain both image as well as the description, right? Like both of the modalities. In this case, only 2 modalities. So your file can be like extended, and this information can be like tied together. Why it's important? It's first of all, it's convenient for you to understand, and second, both of these items needs to land on the GPU at the end of the day, right? For the training, you need the text together with images to convert them to vector and train, right? But it's not enough to have only multimodal data. Also, what is needed in many cases, all the other annotations that you might use. It's needed to manipulate with data set in a more efficient way. We will talk about this later. So it's good to have all the scores next to the data, images, files, text, and etc. Right? For example, in this case, there is some safe score, watermark score, some other auto labels like a size of the image, right? That stuff you might use. Why this is important? For example, let's take an example from the competition. Sometimes you want to filter data based on these signals, right? You want to, for example, remove images that are small, right? Or have like a bad ratio. For example, first image here, right? It has 256 pixels with a huge height, right? Maybe that's not the best image to put in the data set, and it can be removed. So it's very convenient to have this information attached to the file, to the actual signal. So this is how this kind of on concept level how it looks like. You get one modality, data from one modality, data from another modality, maybe annotations, all this stuff somewhere in the storage, or maybe in a databases, or maybe like in storage and database together, and you want to build this like an entity of data set, abstraction. That's one of the way to build it and kind of for improving your efficiency. When each record, it will be like self-descriptable, and you can make like filter, not filter decision and train just based on one single entity. That's very convenient. In terms of technologies, in a simple case, you use like a simple file, CSV, Parquet, Panda data frame, all the stuff. Yeah, I believe you are familiar with really well. But at some point, it's convenient to jump to like more powerful technologies, to databases and use the tables or data warehouses. And usually those decisions related to the scale of your team, how big is team, bigger team is, more badly you need like a centralized place, like a warehouse or something. And scale of the data, right? It's actually hard to say like exact scale, right? Because it depends on your data. But in case of like a datacom, this is like about the scale. Up to 1 million, just go with the simple stuff, right? Later, databases might be a better choice. At some point, you will hit limits of the databases. You need data warehouse to handle like millions and billions stuff. So keep it in mind, right? This kind of stuff. And when you get to the scale of 1 billion, don't even waste time on like databases and stuff, like a data warehouse, like Snowflake or such. That's kind of the approach of handle like billions of records. Collaboration. So when we talk about the scale, it's not only about scale of the data set itself. it's also about data scale of your team. Bigger team is more collaboration you need on the team, right? And in this sense, having a centralized place, it's usually like a good idea and a good investment. When your data set can be in a centralized place, and you can say your teammate, hey, I have this data set, version number 11, check it out. And previous data set, number 10, very likely will be on the same data warehouse, right, on database. So you can compare them and do all the efficient operation together. So at some point, you will get to this pain point. So that's good not only to, it's good for collaboration in the team, as I explained. It's good to save your time on compute. For example, you wanna compute predict some language for your text messages, right? It might be expensive operation. It might require downloading data set. And it's a good idea to do this once and share with the team, and then team can reuse this operation. They reuse this information over and over again. It's especially important when you do this API calls to external APIs, right? You might be using ChatGPT or some other tools. You are paying money for each call, and it's better to preserve this information, keep in a beautiful table, and share it with your teammates. So next time, they can have this opportunity not to call the database again if data didn't change much, right? So it's good to have this kind of caching mechanism between you and the third-party services. And the next challenge people are dealing with is curating the data set, right? We were talking about the data comp and filtration, right? How to remove entities that you don't want. That's one simple example of this data curation exercise. In other cases, you want to clean data, not necessarily remove them, right? But modify a little bit, improve text, for example, right? Or maybe do some translation from one language to another. So using on data comp examples, the operation you can have, let's detect the language and remove the language our model don't perform well, right? Or not supposed to perform well. So one type of operation. Image size, image ratio. We don't want small images, right, like icons. We don't want disbalanced images, banners, long banners, right? Because we know our model doesn't perform well on this. How many people we have on the images, or maybe some smarter ideas. I will show you later. So this example, on this datacom line data set, the distribution of languages, right? English is dominant language, and we know that very likely you're targeting one language, not multiple languages. So you can download all the text, run some model. In this case, it's a fast text model and CLD model, or probably both. And then preserve this information for future filtration. Another idea, it's, as we discussed, right, it's image ratio. Majority of the images have a 1:1 ratio, right? They're squares. There is a lot of outliers. You might need to remove those. The third idea is about people, how many people in the picture. So you might use this information to improve your model. And this is about similarity, right? There is an image, there is a text. If you calculate a clip embeddings for both, you can look at the similarity. If the similarity is completely off, probably it's not a good sample. You probably need to remove this from the training cycle, right? And this kind of distribution can give you some ideas way to make the cut, right? How to put the right threshold. And again, that's super convenient to have this information right into the table, right? Next to your data, connected tightly to your data, and with all the other signals. So in this sense, again, it's scores, safe score, watermark score. You can put text embedding, image embedding, next to it, and then reuse them together. So from one place. A lot of work, especially in the industry, a lot of work is happening in this particular case, right? When you read research papers usually operate on the model architecture and such. On the industry, it's quite different. Yes, you need you have like a high quality data. You have some ideas about the models, but majority of iteration happens on the data side. How to get better labels, how to remove bad ones, right? And that's crucial to iterate fast on this particular stage, on dataset curation. And the challenge is, if all the information is stored on your storages, external databases and stuff, so it might be really tough to iterate on this information, right? You need to download stuff, convert format, process, and only after this you can check your hypothesis, for example, like image ratio or image size, right? The simple one. And the database, if you use a database as a data warehouse, is between you and the storage. That's a way how you can increase speed of the iterations, right? Instead of like asking this question to the storage, instead of downloading stuff, you can just ask this question to the database and iterate through the hypothesis really fast. In some cases, of course, you need to populate this information first, right? For example, to generate language, you need to run models, you need to download text, etc., of course. But once it's done, and probably you spend some resources, coding time and compute time and maybe GPU time, this can be reused hundreds of times by you and your team. So that's a huge improvement in terms of how fast you can iterate, how fast you can get good, better models. All right. What we discussed today. Data part in Gen AI, it's really challenging. A lot of files everywhere, multimodality. You need to merge all the stuff together. You need to get additional signals, compute generate auto labels and vectors, embeddings, and have this somewhere. Scale makes this much more complicated. Your team needs to collaborate efficiently. So that's a really big problem, and it becomes worse because of the scale needs on this quality of the model and such. However, we see this metadata layer, right? The information between your storage as a solution to this. So the metadata part becomes the primary part on this journey. This is what can help you to iterate fast and create better models. And from technology point of view, the databases, data warehouse, that's the way how you can mainstream this. That's the way how you can get maximum value out of this intermediate layer of meta information. How you can check your hypothesis in minutes, not the hours or days, and that's how you can come up with a better model faster. So thank you for your attention. I hope you learned something new about data and generative AI. Happy to answer your questions. Please.
Yeah, I have a question. My first impression was like DDC looks pretty much like a feature store. It solves a very similar problem. So in what sense it's different? Yeah, that's what I'm trying to understand better. Thank you.
Yes, good question. So first of all, yes. Second, it depends what do you mean by feature store, because they're like a kind of like a two definition of feature store, right? One is that's the place when all the features like combined and stored, right? And the second definition is like it's a dual database when you have all the features together, which can be used for analytics and serving, online serving at the same time, right? If you're talking about the first definition, you're absolutely correct. The difference is it's focused for unstructured data. Means it does include the quote a detailed process from storages to the feature store. It has a component to keep consistency between storages and this feature store, right? And again, it's focused on this like images, embeddings, text, etc., right? But in general, conceptually, yes, this approach is it's all about like feature store. Yeah, please.
Hi. So I guess my question is how this will help businesses or companies save costs on like maybe accessing ChatGPT or like the public models which are costing which are charging money for for answering any questions that they have. Like, how are we trying to save costs on the requests that we send to them?
Yeah, good question. So if ChatGPT charges you like 2 cents per call, right? It charges you 2 cents per call, right? You cannot optimize this part. However, you can be more organized, first. And second, you can be more efficient in terms of like how you share this information with your team and actually with yourself, right? So if you keep track of all this like API calls, keep them in some centralized place, it helps you not to make call that you don't need down the road, right? And this kind of just a framework to be organized in this way, to keep track, see what was already called, what you paid already, and make a decision if you need to call it or not to call next time. Any other questions? All right. Then I think that's it for today. Thank you again for your attention. And we have a booth number 5, I believe. So if you can chat more or see like how it works, please join and happy to continue the discussion. Thank you again.